Hello, everybody. Welcome back to Does Science Really Work? The official podcast for the University of Calgary's iGEM team. I'm your host, Khadija Abbas, and today we have a very special episode lined up for you. You know how math often gets a bad rep for being hard, dull, and something only geniuses can do? What if I told you that one of the most beloved profs at the University of Calgary teaches exactly that, and students can't get enough of her? I've never seen anyone with as many Rate My Profs reviews as her, and with majority of them being 4 out of 4. Today, I have the absolute pleasure of sitting down with Dr. Mayada Shahada, PhD in mathematics from Western University and an assistant professor here at the University of Calgary, and someone who's made linear algebra a fun option. We're going to dive into her journey, her passion for teaching, and how she brings a subject like math to life in the classroom. So, thank you, Dr. Shahada, for taking the time to join me today.
Thank you for having me.
Yeah, so both my friends and Rate My Prof say that you make math extremely fun. I took linear algebra and I feel like I really didn't take it compared to like how they tell me how it's so fun. How did you bring that course to life? What did you do to like make it so engaging?
Um, I think I believe that most of the professors, math professors, maybe in particular, they focus on the part of how uh, in teaching. So, how to solve this equation, how to find the value of x, and all of that. But I believe that students would learn more if you combine the how part with why and where. So why do we need to learn this? Why we do it in this way, not the other way? And where we will ever apply this in our life or in our future courses if you are in our program. So this is what I try to implement in my teaching is to combine these three important components, and I believe that it's working well from the students' experience and feedback that I'm receiving is that once you know what you are doing and why you are doing it or where you are going to apply it, would complete the learning process. So this is
So like
basically what basically I build my teaching on.
making meaning out of the math instead of just like learning to use as a tool.
Correct.
I see. So
Yeah.
it's really interesting. Like how did you learn that that was a correct approach? Did you have to like play around in the classroom seeing how students were engaged, like shifting, like because like
Um,
you seem to be very successful. I've seen Rate My Prof a lot, and you have a lot of good reviews.
Yeah.
Yeah.
So I was privileged to have my father, who's
Mhm.
also a mathematician, and
Nice.
who was the person after who's inspired me to become a good math teacher. So uh, yeah, since I was a young kid, my father was the person of behind loving me, loving the subject, and then becoming try to become like him, like a good math teacher. I remember when I was young that we have like a whiteboard instead of our head board, and we every morning we wake up onto a question or a puzzle for me and my brother to solve before we come to the breakfast table. So I found I was going to bed early and try to waking up early in the morning, just looking forward for that challenge that it will be posted in that board by my father. Um, and another person who was behind all of this is a teacher, a grade 9 teacher. I was till grade 9 I was an average student, so I was scoring like 80%, 85% as max. But I had that teacher that sparks the love of math. She was a math teacher, but she changed my life. I mean, she changed my the way I look into all the subjects, not just math. From the way that she was, teaching us. Um, every day, class was like a challenge to solve, was a puzzle to crack, and something like that. So she built the subject in that way. And I remember that I was like, I don't know, 82% student in the first semester. And then after I taking that course, the math course with her, I become like a 95 or 97 percent student.
Wow.
So she was also inspiring to be okay. I would love to be like her. Loving the subject, basically loving the math was behind my father, and loving giving that math or giving that knowledge in the way that I'm doing it was because of that teacher. So
Wow.
this is what I believe that would inspired me to go into this journey and
Mhm.
become what I become
That's
into.
so
Yeah.
like having that support system of first off your family was there, your father was very like supportive of your like educational
Yeah.
like journey through math, and then like I've had teachers like that too, like who just like make you feel capable of doing like a really hard
Right.
subject,
Yeah.
and then it changes like everything. So like
Correct.
what made you like besides like your father's influence in your life of having like those math questions every day,
Yeah.
what made you decide that like math was something that you wanted to go all the way to PhD level? Like,
My aim is that I was always looking into become a math teacher, but the satisfaction level wasn't enough to
fair
be
enough.
like just teaching math into high school students. I
Mhm.
started with my journey on my teaching career to be a high school teacher first,
I see.
but I thought that this is not enough. I would love to be challenged more into math and excel more into the subject, looking into ways, its beauty, and ways to apply, and crack these problems and try to, to find solutions for something that is not,
Yeah.
has no solution yet. So that's why I was, insisting into having my master's and then having my PhD. And I believe that good teachers should combine the two part of the main process, which is loving the subject itself and having ways to communicate that subject. And I was lucky to have supports from my family, and have some people around me also that supported me in that. Loving the subject and loving to be challenged more in the subject, and at the same time having ways to communicate what I have known or what have learned, and give it back to others.
I see. So like
Yeah.
would you say that like I think especially like coming as like from like I don't know, like a hijabi female, like there's a lot of just in the role of just being a female, there's a lot of societal expectations. How would you say like your support system has like helped you with that? Like, for example, like as you went through like your degree, as you're like you went through higher education, it took a lot of like a lot of years, right? So how would you say like your support system shifted and how did that support you through that?
I didn't feel that being a female and
Hmm.
being like
Yeah.
a Muslim or
Yeah.
hijabi was something prevented me from
Hmm.
achieving what I'm
Hmm.
looking for to achieve. Not at all.
Hmm.
I mean, the environment that I was in, and where I get my PhD,
Yeah.
the people around me give me
Hmm.
the support that
Hmm.
let me achieve, and
Hmm.
go to what or achieve my goals basically, and go
Hmm.
to the places that I wanted to go.
Hmm.
Yeah, and it's not just the people. I mean, once I become a teacher, also my students, I felt they gave me the courage to keep going.
Hmm.
Um, um, hearing the aha moments and the laughs that the students would have
Hmm.
in my classes, and oh yeah, now we get what we are saying. Now we see why we are doing this. All of these comments push me further into doing what I'm doing. So
Hmm.
yeah, so it's not just like family support or like other members in my education system support, but it's even the students themselves
Hmm.
give me also the courage to keep going and doing that.
Wow. Yeah, I can imagine. I've heard so much about like how your classes are like they're like linear algebra, like they're very like engaging, and even still like people tell me that like they really like linear algebra, which I was like, oh,
Oh, this is
yeah.
this is the ultimate goal, is to
Hmm.
switch these, the way they look into the subject.
Hmm.
Basically, this is my main goal: is
Hmm.
that math is not a dull, boring subject. Everybody has the possibility to do math and to excel in it. and you should enjoy doing it. It's not like you have to suffer doing or learning something, and you should also see where you can apply what you are learning in your life.
Hmm.
So
Yeah, like I felt like you seem like you have you do like a lot of very interesting work. Like you do math to an extremely high level, and you also are very amazing to teaching. How do you balance that? Because like I've heard that for teaching professors, they focus mainly on teaching, but do you also do research on the side?
I do, I
Hmm.
do. So I do research in my background,
Hmm.
but being also a faculty member in the teaching stream, I would have also the ability to do research in mathematical education. So, coming with a new ways onto into and methods into teaching. Yeah, so I have the ability to do both, but teaching is my passion basically. So probably I'm focusing more in doing research on and teaching more than in my subject or my.
And what's your subject, by the way?
So it's commutative algebra. So
Big words.
yeah,
Yeah.
so it's a big words, but we could say that I can explain that in an easy thing. So
Please.
algebra is basically a language where we use symbols like X, Y, Z, and notations, operations, addition, subtraction, and also numbers
Hmm.
to express situations or to model situations. And being commutative, it means that we could commute things. When you apply an operation, you can apply it from both sides. Like x times y, it's the same as y times x.
Hmm.
So commutative algebra is a way to model situations in our life using equations, using basically it's polynomials for me, but using equations, expressions, and then study these expressions from an abstract point of view, and then understand the situation or get information about the situation that you are modeling using these equations.
Hmm.
So this is basically the main research that I'm doing. Um, but at the same time, I'm also doing research in the teaching field as well.
Hmm. So like the stuff that you're doing research on besides teaching is very like abstract in the sense that you're trying to figure out relationships of equations.
True.
I come from like I used to be like a physics background, and one thing I found for me personally with physics is that I wanted like my life goal to have like an impact and stuff like that.
Right.
So like how do you find that? Because I feel like math and physics, they're both theoretical in that sense.
Right.
Is that impact for you like through like the teaching aspect, or how did you find like impact in your work? Because that was just like a personal thing I had.
Uh-huh.
Was it similar for you or?
Yes, when you use something abstract in modeling something you
Mhm.
you live with, like for example, if um, like a connection system or a transportation system, you could model this using something called graph, and from the graph you can come up with some equations. Like, for example, if you have two cities and there's some connections between these two cities, you could model the first city as X and the other city as Y. And then if there is some connections between these two cities or some transportation connections between the two, then you can model this by a monomial, which is X times Y. So it's something we see, something we can experience in our life, but you could model it using something totally abstract, and then you could play with these abstract objects and try to understand the relationships and what kind of information you can extract from them, and then reflect that back into the situation and understand how these relationship that you get out of these polynomials or out of these relation equations from an abstract point of view into how that would give you information about the real situation. So this is the fun about math, is that it's easy to go back and forth between your real life and your imaginary life, let's say. So you are imagining things, but you use these imagination in modeling something you see in your life. So this is the beauty I can see about math, that it's totally abstract, but it's very very useful and it's very fun to play with, basically. So
So it's not as abstract as I was
It's
thinking.
not. It's not
I see.
totally. If you look
Hmm.
into it in that direction,
Hmm.
it's totally not. It's very fun. I mean, it's enough to have that satisfaction of solving or cracking a problem that even if you can't see how this is applicable to your life, but only having that satisfaction of solving something that nobody been able to solve is something. I mean, it's feeling incredible feeling for my from my point of view at
It's like
least.
being
Yeah.
able to like logic out a problem with like your own.
Yes.
Like, yeah. I
Yeah.
remember like when I was in physics, like I love that aspect of it. It's like I can actually solve it myself, you
Yeah.
know?
Yeah.
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 So,
Yeah.
yeah.
Yeah, and
Mhm.
what I try to make my students feel is that you can do it. I mean, everybody can do that thing. You have the ability, you are capable to do these things, and you should not be afraid of doing it.
Mhm.
So I think this is my turn, or my all professors' job is to make that possible for students, to let them feel that they can do it,
Mhm.
because everybody do it, So why not you? You can also do it. Yeah.
You sound like a really good prof because I remember one of the most impactful teachers for me. She was someone who also made me feel like I was capable of, like, for example, like doing physics, right?
Yeah.
And I just remember like the amount of impact she had on the last day when I was like with like when I was leaving high school. I just remember I went up to her and I sobbed in her arms because I was like, I can't believe I'm like going
Yeah.
away from you. This is insane. So it's like
Yeah.
she also had a similar like attitude to you. So
Hmm.
like I can just tell but from that conversation you seem like a really good teacher. Yeah. So you seem through our conversations, you seem very, very successful in your teaching career. And I remember stalking you a bit and reading up on how like you worked at the University of Bahrain and then you also held a workshop with LUMs for like young girls and students. What inspired you to shift from like your successful career here over there to over here in Calgary?
Um. Well, I came back to Canada for the family. So
I see.
um, I was there. I was here in Canada, and
Mhm.
particularly Nova Scotia, Halifax.
Ooh.
And then the pandemic hit, so I got panic a little bit. I wanted to spend some time with the family, so I went back to Bahrain, and I worked there during that time. And then the hope was to have the whole family moved back to Bahrain, but this is nothing didn't happen. So,
Fair enough.
my husband stayed here in Canada. So, yeah, and then I found this opportunity to come back to Canada and work here at the University of Calgary. So I came back.
Oh, okay.
Yeah,
I had also a similar thing for me. Like when I was like still a student, I was studying here, and then right before the pandemic hit, I was in Qatar. So it was nice being with my whole family. Kind
right,
of a nice time.
correct.
So that was really nice. Yeah. And then, so what difference did you notice when you went over there? Is there a difference in like teaching style compared to here? Like, what are the main differences?
Well, math is an international language, let's say. So there's no basically differences between the material that we present to students there and the material here. It's almost the same. Probably maybe the students' background is a slightly different because of the education system and and in schools, in public schools, or the education system for high schools in general is slightly different between back there and here. But I can't see any huge differences, and yeah, I can't see any differences basically between my experience there as a professor and as a professor here. It's almost the same.
Was a lifestyle like a little different though, or like,
Yeah,
uh,
I mean, yes,
yeah, fair
the
enough.
weather is different first.
Yeah.
Yeah, and it was basically a
Mhm.
big shock because I lived in Nova Scotia for a long
Mhm.
time, so the weather is mild and humid.
Well, at least they have that in
Uh,
common. Yeah.
yes, yeah, but it was a bit dry, and the
Mhm.
winter are harsher
Mhm.
here in Calgary. But other than that, I mean, in terms of living styles and in terms of work and teaching, I think it's almost the same.
I see. And then in regards to like research interests, do you feel like did you notice any trends in Bahrain versus in Canada? Like in math research, it was just like everyone does whatever they're interested in, or was there a general trend like, oh, they were interested in more a different sector of math while it was different over here?
Usually for math departments, we have like research groups, so
I see.
where they do
Hmm.
research in different branches of math,
Uh-huh.
and I can see also the same thing here. I
Uh-huh.
mean, there is like research in algebra.
I
There are
see.
some research in number theory, for example,
Uh-huh.
research in applied math and all of that. So which is also available up here. So. Um, I think everybody in a specific or when you do your PhD or when do when you specialized in a research, you specialized in a very small part
I see.
of the subject. You cannot do research in all
Girl.
math. You have to be more specific in one of the branches or one of the path. And I feel that everybody they see that their path of research is the trend.
Uh,
So
mhm.
when you are doing something, you would always look in what is happening in that part or in that path that you are in. So everybody sees that what they do and research is the trend right now. So which is nice because you can in this way you can cover the whole different paths in the subject, and you wrench more into it.
I see. So it's like everyone, when they start doing the PhD, goes into like what's popular in that sense right
Exactly,
now,
yeah.
and then but
Basically goes
uh-huh.
into what they like.
Oh, I see. I see.
Yeah, so
Uh-huh.
you pick the path that you feel that it's attracting you, and it has like interesting questions that you would like to address or you'd like to resolve. And yeah, because you in math there is different paths and different ways, branches in math. So in doing your master's is like general scheme of what is happening out there, but in when you do your PhD, you will be more specific and picking which path you would like
I
to
see.
excel in.
Oh, really
Yeah.
cool. And then also, like we were mentioning before, how you did a workshop with LUMS for young
Yes.
girls.
Mhm.
Like, how was that? Like, what inspired you to do that? And
Um, so when I was in Dalhousie University, I was a postdoctoral there. And I was also the director of an outreach program
mhm.
called Nova Scotia Math Circles. So um, one of the faculty members and alums came for a visit during when I was there as the director of that outreach program, and they left, and then I moved to Bahrain for my position there during the pandemic, and then the connection happens again. I said, okay, I'm now a chairperson in the Department of Math at LUMS, and I would love to have such program built in the university, and said, okay, I will be happy to come on visit and maybe do like a small workshop about what I did and how we can build up this thing. And it happened, and I asked them, okay, why not to invite other universities in Pakistan as well to have that experience. It's not just for lumps, and this is basically what happens. I mean, I think it's the science ministry there in Pakistan, along with Malala Foundation, funded that program. So they built up this workshop and they invited like 23 different universities
Wow.
all over Pakistan to come over and attend, just on how to build up such a program. I feel that universities or colleges or higher education institutions should be always in connection with high schools, with schools, public schools, because their graduate are our freshmen coming
Mhm.
over. So to ease the transition going from high school to a university, and to make that transition easy to those students, um, they would it's always good to have that connection. So how to give back to schools, how to show that what we are doing in our research is important, and how we can recruit students to excel more in the STEM courses. I mean, especially girls and females. Um, So this is was the main idea, is to create such an outreach program for which, university faculty members would go to schools, throw them a visit, explain or communicate the research that they do in a, using general words, and everybody can understand these words, hands-on activities, how to enrich the subject and make it more enjoyable for the students. Um, so I was also, lucky to found such a program in the University of Bahrain, which was the first in the region. And I was also lucky to have or to run this workshop for Pakistan as well.
That's so nice, like increasing like your reach as like that teacher who's able to show that people like students that they're capable of doing this.
Yes.
And now it's like such a big impact thing, like 23 universities, they're going to multiple schools in Pakistan. That's
Yeah.
that's a, that's that's a very big impact.
Mhm.
So so one thing would be, what do you think you, through your experience, like doing all of this outreach, like what is the biggest lesson you learned through like working on such big projects such as these?
What is, sorry, the impact?
Or like the biggest lesson that you learned that you wish that like maybe like other teachers or professors could know to also like have the same level of impact?
Yeah, I mean, there is the way that the math is taught in schools
Hmm.
is slightly different than we teach math in university.
Hmm.
So filling in the gap between these two main, let's say, stages in the students' lives is very important. And this is was the point behind these outreach programs, is that we are going to schools not to teach students, not to fill in what is missing from the teacher side. It's more into, okay, how to enrich this, how to make the math more accessible, more easy, more interesting for the students. Um, what we do through these outreach, visits or programs, is that we take problems, some of these problems that they are still unsolved in math, and then introduce them in a much more, in a fun way for the students. um, you don't know. One of these students might be a big scientist, and then in the future they might be able to offer, a solution to these big open problems that they are not solved yet. So this is the main idea: is how to make the subject more hands-on, more engaging, more fun. Look into it in a different way. Feel the importance of the subject,
Hmm.
not just to have a degree, you have to take these courses, right?
Hmm.
No, you want to learn.
Hmm.
You want to go to these classes and have something that will be beneficial for you.
Hmm.
So
So
this is what we aim to do, and I feel that the journey is not just for ends with schools, students in the schools, but it has to be continued till you graduate. I mean, you you need to be learning till the time you die. There is no ends of learning. Um, so we would like to have or to change this idea for students.
so like emphasizing how studying isn't just about coming to like end, it's actually just about the learning process
The
in that
learning
sense.
process,
Hmm.
and give it away. I mean,
Uh-huh.
if you learn something, how to give it away back
Hmm.
to somebody else. So it's generations giving another generation.
The
This is how we
preference.
look to the subject. It's not, I'm not teaching the material, I'm not teaching theories and doing examples on how to solve equations. It's rather than changing your mind about the subject, how you look to the subject, how this subject would affect you and change your life to be a better person.
So like active learning versus just passive learning, like
Exactly.
with the growth mindset type of thing
Right.
where you're like always learning.
Yes.
So like trying to reinforce that in students.
Right.
And I remember you just mentioned that you tell them about like unsolved math questions.
Right.
What's the most interesting one you've run into? Or like,
Unsolved.
mhm,
Um, so the patterns of prime numbers. So a prime number is a number that has only two factors, which is one and itself. like for example 2, which is the only even prime number, and 3, 5, 7. So is there is a pattern for which these prime numbers goes
Like
on?
the
Is there is a formula for which you can just sub in the location of the prime number that you are looking for, and then using this formula you can get the value of that prime number? This is one of the open problems that they are basically opened to the public, and there is some money allocated to it to whoever be able to solve it. So, and theorists, I mean, number theorists are still working on that. How can we find a pattern for which prime numbers are,
So it's like, is that the Fibonacci sequence?
Sort of,
Oh.
yes, sort of. So, yeah. So the Fibonacci sequences follows some pattern, which is every term is just the sum of the previous two terms.
Oh, not the prime.
Yeah. So, but the primes are not. I mean, if
see.
you look into 2, 3, so the difference is 1, and then 3, 5, there is 2, and then 5, 7, there is difference is 2, and then 7, you have 11, there is a difference of 4, and so on. So, what is the pattern that these prime numbers follow? This is something unknown.
So there's
now.
a known equation. There's supposed to be an equation out there, but that's not found out yet.
Is not. Probably there's no. We don't know.
We don't know. Okay.
Yeah, we
that's
don't
one
know.
of the that's one of the big like
yeah.
questions.
Yeah.
Okay. That's really cool. The whole like the concept of like the unsolved problem. Given that like it's very like all these questions seem really cool. Like if you were to design like your very own math course, what would that look like? What reach would that have? How would that go?
I would love to design funny math course.
Funny math course. Okay.
So I always see that math would be fun if you go back always to the basics, understand the basics, how we multiply numbers, how we add numbers, and why we're doing it in this way, and all of that. Look into the basics and then play with it, play with these things, and have fun with it. So I would love to have like a math course just to have fun with math, not just not required to your program, or not required to do to excel in your programs, but just to have fun.
So like
with math.
What would the target audience look like? Like would it be
It will be open for everyone. I
Everyone.
mean, everyone. Yeah, everyone, even senior students. Yeah.
So it would be like you going over like what's the reason we multiply? What does
Right.
that actually look like and stuff like that?
Exactly.
It's like,
yes. Yeah. I mean, look into the the facts, because sometimes we look into easy things as facts that we talk, but do you understand the what behind these facts? Why we are we believe that this is true? Why 1 + 1 = 2? Why do we believe that this is true? So if you look into math in this way, like you need to be convinced before you take something for granted that it's true. And this would be my job, is to convince you that, well, this works and this is why it works. And then, okay, we have these fun tools, how to play with them. Yeah.
I remember one of our last podcasts was with a philosopher, and we were talking about math. We talk
Right.
about math a lot now, but we were talking about how math itself is a kind of philosophy, right? So like even like they brought up the example of if we have a drop of water, 2 drops of water, and we add them together, like they
merge, yeah,
we get 1 drop of water. So like given that, and how the your course would go over like the more basics of like why do we add, why do we multiply, and that type of stuff.
Right.
Do you think that it's possible to like is math still a philosophy, or is it's still possible to?
I believe too. Yes, there is a nice book called or named God Create the Integers, and and there is another book also that's called the Math Book. These two books are more into philosophy and math rather than math. So they go over and represent the most beautiful like problems solved in math, and the history behind it, and the way they represent it, and the way they proved the theory in it, but in a very easy accessible way. So they are very fun to read. Usually I have these books in my bedside. Once I feel that I need to take myself out of something, I always go and read these books. I mean, explain why 6 divided by 2 equals to 3, for example, or what is the difference between a point and a line, and which one we use to explain the other one. Is the line infinitely many points glued together and they follow a specific pattern, or is the point is a line with low length? Which one comes first? It's like which comes first, the chicken or the egg? So it's something like that. I mean, it's super fun to think about these things, and why we are taking these things as granted that they are easy. So, and I believe that students, once they are convinced truly why these are things are facts and why they are true, they will stick. I mean, in their mind, and they will never forget it. What is unfortunate is that students, once they write down their final exam, they just throw everything and go to the next course, which is bad. I mean, math is a skill you should carry with you all over. It's not just a subject you need to write their final exam and then you finish with it.
It's something that can be applied in a broad number of fields. I
Right.
remember we were talking like before about how math can be applied in like a diverse field like biology, for example. Do you mind going into like how is math applied here, or like even in like sciences where it doesn't seem like math is applied?
Mm-hmm. Um, well, one of the funniest maybe stories I would explain, I would say, is that when I was in my bachelor, I took my bachelor in math and, education from University of Bahrain. We had like a debate between a math professor and a physics professor, and
Intense.
the debate was which which one of the subjects came first. Is it the math or physics? And the start was by the physics professor. He said he bring an ayah from Quran, a quote about the earth and the sky. Um, and then the mathematician or the math professor said, which ayah was that? What is the number of that ayah?
Oh
Was
wow.
that? Which one came first? I mean, at the end, after the whole debate and going back and forth between the two, we come up that there is no distinguish between the two. I mean, you cannot. Well, it's all sciences, and they are connected in somehow. So in biology, you would find math. In math, you would find also biology. I mean, there is a connection between all of these sciences in some sense, and you cannot take one of the subject or study one of the subject without you know going into the other one. I mean, in chemistry, you would use weights and convert between units, and all of that would have math involved in it. Although you are studying like, substance, and and the same thing for biology. When you study, living things, you would see the amount of oxygen they are taking or they are using, how much, the weight, all of that things. I mean, you would see that you would find math in there. So it's not like math is a side away from the other sciences. All of this should be called a science. All of that you cannot distinguish between all of these, and this is how we look to math. That it's part of something that we need to learn so that we will understand our world much better.
So it's in every single field, and we should. That's why universities make all of us take so
Yes.
many math courses, even no matter what field you're in.
Right.
Yeah.
Yeah.
So we were just talking about if you could design a math course and its ultimate math course. Sounds like a really like fundamental and useful math course. So, do you mind explaining to me why can't we divide by zero?
Okay. So maybe it's to explain this. It's better to explain what division is. So what is 6 divided by 2?
3.
It's 3, but why it's 3 and not 4, for example?
I don't know.
Okay. So division is an operation that is opposite to multiplication. And multiplication is just repeated addition. So 2 times 3, it means you add 2 to itself 3 times.
Mhm.
Or you add 3 to itself 2 times. So in both ways. So when you when you ask 6 divided by 2, is another way to ask this question is that how many times you need to add 2 to itself to get 6. So you need to add 2 to itself 3 times to get 6.
Unless it's a water drop.
Yeah. And if you look now to dividing by 0 into that way, like for example, if you are dividing 1 divided by 0, why this is not possible or why this is undefined. Well, if you look to it in the same way that we look into 6 divided by 2, is that how many times you need to add 0 to itself to get 1.
Infinite?
So there is no way, right? If you keep adding 0 to itself, you always get 0. You will never get 1. So that's why it's undefined. So that's basically why we cannot divide by 0. It doesn't go with the division concept and the multiplication concept, the basic operations
So
concepts.
given that like it's a number, yet it doesn't act like the other numbers, why is it in the same category?
Asian people, when they were doing math or expressing numbers, for them, 12, 102, 1002, all they will be written in the same way. The only difference is that they will keep some space between the 1 and the 2. But how big the space should be if we have compare between 102, for example, 102 and 1002. What is, how can we distinguish between these two numbers if we would just separate the 1 and 2 with some spaces? So this is where the idea of Al-Khwarizmi, when he come with, okay, why want not to create a number that holds the space of something that is not there? So it's nothing that represents or that holds the space of something that is not there. So this is where the idea of having 0 added to the system, to the number system, and once we have that 0, calculations with big numbers become very easy. So, and expressing these numbers. So now it's very easy to write like a 12,201, for example, or something like that. I mean, it's very easy now to express big numbers and also do calculations with big numbers. But once this number was represented and added to the number system, now mathematician would ask, okay, what other things? How can we deal with this new number? How can we multiply with it, or how we can this number be involved in the basic, operations in math? So yeah.
So is it really a number or no?
For me, it is a number. It's very important. But it's very fun. I mean, you could look to it as nothing, or you could look to it as a number that is very important to represent.
On buying chunks,
Yes.
it's important, and like a few extra zeros on mine.
Yes. Yeah.
All right. So I'm going to throw you some rapid fire questions now.
Okay.
If you could have dinner with any mathematician, living or dead, who would it be?
Okay. I think Leonard Euler.
Euler.
Yes.
Oh, you switched up.
Yeah.
Why?
Yeah. Well, he's a physician, I think, but
okay.
is it
Da Vinci or
no?
Oh.
No. It's Leonard Euler.
Okay.
Yeah.
Oh, the E guy.
Yes, the
Okay.
E guy. Yes. And the reason why he has a very fascinating, life. I think he lived till he was 40 years old, so he died young, and the majority of his life he lost his sight.
Oh,
during that
that's why he went to math theory.
Yeah. So, but he was the father of graph theory, which is a very big, huge, and branch of math that has many, many applications. So I would be happy to have dinner with him, and probably ask him some questions how you're doing math. I mean, to have a PhD or to be qualified to have a PhD, you need to publish some papers. So usually it is expected to have like 2-3 papers at the end of your PhD, which usually takes like 5 to 6 years to do. Euler was able to create a paper every week for about, I don't know, till he died, and during losing his sight. So you can imagine if he stays alive for a longer time,
Yeah.
how the math would look like.
We'd have AI 10 years ago.
yeah,
100 years ago.
there are some of the theories that they are still in there, but documented as results, but there is no proof to them. He had the proof, but I think he had them in his mind, and he didn't have the time to express the
Mhm.
proofs. And they until now we don't know the proof of these theories.
We should just take it as
So
fact then.
yeah,
He was right about everything
yeah,
else.
yeah. So
Mhm.
yeah, this
That
is
would
the
be
mathematician.
that would be
Yeah,
the one you'd
would
spend lunch
look at
with.
yeah, spend lunch.
Okay. So, next question. What's the most non-mathy thing that would surprise your students about you?
I love cars
Cars.
and speeding in cars,
Speeding
but
in cars.
maybe
This is going to be on camera.
but maybe the most thing maybe unexpected is that I drive a motorcycles as well. So
Wow.
and I'm having fun with them. So yeah.
That's so cool. Oh my gosh.
Yeah.
I always wanted to learn how to drive a motorcycle. I asked someone and they're like, don't do it. It's so dangerous.
It is super fun.
Ah,
Yeah.
that's going to be my motivation. I have to get my driver's first, but.
Yeah.
So, and then if you weren't a professor, what would you be doing right now?
I would be wedding designer.
Wedding designer.
Yes.
Wow.
I love fashion, but wedding fashion to be exact, and wedding parties. And I can see myself to be a wedding planner or a designer in some sense. So yeah.
Wow. And like I don't know, for my culture, there's like weddings take like they're like a huge event.
Yes,
Same for
they
yours.
are
Like you.
very important. And I was lucky to have 3 daughters,
Oh, nice.
and I'm looking forward
Oh.
to plan their weddings.
That sounds so stressful though.
No, I'm excited. I would like them to start that journey and
And my mom was saying too, like, because it's such a huge thing. Like, she bought a plot of land and she's gonna sell it for our weddings because it's just so like it's huge.
yes, yes.
And then, if you could describe, we were talking about your teaching through this podcast. If you could describe that whole philosophy in 3 words, how would you do it?
Possible,
Possible.
enjoyable,
Mhm.
applicable.
Applicable.
Yes. So
Okay.
math is possible, which means that everybody can do math. Enjoyable, you should enjoy while you are learning math. You don't need to be miserable. And applicable is that when you learn math, you learn it to apply it somewhere or to use it somewhere. So this is what I aim to make math into.
Oh.
Possible, enjoyable, applicable.
Oh. I think that's those 3 concepts are very, very important. And I think that's honestly a great way to end off this podcast.
Thank you very
Thank you
much.
so much.
Thank you
Yeah.
very much for having me.